Welcome to the unit on differentiation. In this unit, we will be looking at key concepts through review exercises. The objectives for this session are to review previous topics through exercises, namely, find the equation of a line given the gradient and 1 point on the line, or 2 points on the line. We will also understand the laws of indices and apply these laws to algebraic expressions to simplify them, and find the equation of a perpendicular to a given line. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. The gradient of a straight line is its slope. It is calculated by dividing the vertical distance by the horizontal distance between the points. Suppose a line is joined by the points x1, y1 and x2, y2. The vertical height of the right-angled triangle generated by this line is y2 minus y1, and the horizontal length is x2 minus x1. The gradient m is therefore equal to y2 minus y1 over x2 minus x1, as shown. Let's now take a look at an example. Find the gradient of the line which joins the points minus 3, 8 and 3, 6. We can draw a sketch of this just to give us an idea of what is happening if we need some clarity. So therefore, m equals y2 minus y1 over x2 minus x1, which equals minus 2 over 6. And this is of course equal to minus 1/3. So the gradient m equals minus 1/3. Let's take a look at another exercise. Suppose the line joining 3, minus 7 to 8a has gradient minus 2. Work out the value of a. Now the gradient m is equal to y2 minus y1 over x2 minus x1, as shown. Tidying up gives a plus 7 over 5. We know that this is equal to minus 2. Now solve for a. Multiplying out, a plus 7 over 5 equals minus 2, gives a plus 7 equals minus 10. And finally, rearranging gives a equals minus 17. We will now look at the laws of indices. The laws of indices shown on your screen can be used to simplify powers of the same base. Let's have a go at exercise 2a. Simplify 3 to the power 5 multiplied by 3 to the power 6. Since we are multiplying two numbers with indices, we will be using the law highlighted on the screen. And of course, since we are using the same base, we must add the indices, as shown. So we have 3 to the power 5 times 3 to the power 6 equals 3 to the power 11. Now let's have a go at review exercise 2b. We are going to use these laws of indices on our screen to help us solve this. So we are required to simplify the cube root of 8x to the power 12. We are going to use the second law, which has been highlighted. So we have 8x to the power 12 raised to the power 1/3. We can write this as 8 to the power 1/3 times x to the 12 to the power 1/3 to give us cube root of 8 times x to the power 12 times 1/3. And of course, cube root of 8 is 2, and x to the power 12 times 1/3, we simply, of course, multiply 12 by 1/3 to give us 4, as shown. And so our solution is 2x to the power 4. And now for review exercise 2c. Simplify the expression shown on your screen. We begin by splitting the expression as shown. And now subtract the indices as shown, here and here. We can do this as we're using the same base. And tidying up. And finally, we can express this as 3 over x cubed minus 1 over x to the 5, as shown. And now for exercise 2d. Suppose that y equals 1 over 125 x cubed. Express y to the 1/3 in the form cx to the power m, where c and m are constants. So let's rewrite the expression for y, substituting in the value y equals 1 over 125 x cubed, as shown. And now split the expression in brackets as shown. And now rewriting this expression gives us 1 over cube root of 125 multiplied by x, which of course simplifies to 1 over 5 times x. We are now going to revisit straight lines again, and gradients in particular. So let's take a look at an exercise to illustrate the theory. Find the equation of the straight line passing through the points 2, 10 and -1, -8. So let's solve this. Now the gradient of the line is m equals 10 minus -8 over 2 minus -1. This equals 18 over 3, which is 6. So m is equal to 6. If we suppose xy is any point on the line, then m equals 6 equals y minus 10 over x minus 2, and therefore multiplying out gives the equation shown. Finally, tidying up gives y equals 6 times x minus 2. Now let's have a go at review exercise 3b. Suppose a straight line has gradient 7 and passes through the point 4, -1. Find the equation of this line. So let's solve this. In this case, we have one point on the line and the gradient. So for a general point on the line, we can substitute as shown. Now m equals 7, and this is equal to y minus -1 over x minus 4. We can rearrange to give us 7 times x minus 4 equals y plus 1, which implies when we multiply out the brackets, 7x minus 28 equals y plus 1. And finally, tidying up gives us y equals 7x minus 29. We will now take a look at perpendicular lines. Perpendicular lines are at right angles to one another. Suppose L1 and L2 are perpendicular lines with gradients m1 and m2. Then m2 equals minus 1 over m1. And of course, m1 times m2 equals minus 1. We can see this if we put triangles as shown on the diagram. These two triangles are congruent. And if we find the gradient of each of these lines, we have that the gradient of L1 equals A over B, and the gradient of L2 equals minus B over A. Let's now take a look at review exercise 4. Suppose the line is perpendicular to the line 3y minus 2x plus 5 equals 0 and passes through 3 minus 2. Find the equation of the line. Let's solve this. Rearranging 3y minus 2x plus 5 equals 0 gives us 3y equals 2x plus 5. So y equals 2/3 x minus 5 over 3. A line which is perpendicular to this has gradient minus 3 over 2. Since the two gradients multiplied by each other give minus 1. So the equation is y equals minus 3 over 2x plus c for some constant c for this perpendicular line. Now, we know that y equals minus 2 when x equals 3. So we can plug in the values in order to find c. And therefore we have that c equals 5 over 2. So we can now substitute c in the equation to give y equals minus 3 over 2x plus 5 over 2. So this is the line passing through 3 minus 2, which is perpendicular to 3y minus 2x plus 5 equals 0. This brings us to the end of this session. If you have understood its contents, you should be able to find the equation of a line given the gradient and 1 point on the line or 2 points on the line. You should be also able to understand the laws of indices and apply these laws to algebraic expressions to simplify them, and find the equation of a perpendicular to a given line. Thank you very much for listening.